Okay, so when I was going through the trig derivatives, I just sort of shot over this one. I said y equals tangent x, and that means that dy dx is equal to secant squared x. Now we're going to go and we're going to do it two different ways, because what we just did in the previous video was we did quotient rule, and so now we're going to do quotient rule along with chain and product rule, and we're going to prove this two different ways. So first off, quotient rule. Well, quotient means something divided by something else. Well, so we have to remember that tangent x is sine x over cosine x. So then my u is sine x, my v is cosine x, my u prime is cosine x, my v prime is minus sine x. And so then we have y prime is equal to, this is where we have to get the order correct. So we get y prime is equal to cosine x times cosine x minus sine x times sine x all over v prime, which is v squared. So I'm going to get y prime equals cosine squared x minus, so that's plus sine squared x all over cosine squared x. Now we have to do a little bit of a leap here. Cosine squared x plus sine squared x, from our Pythagorean identity, that's 1. So I get 1 over, I'm going to write it this way, and that's bam. Let's do it a different way. Y equals sine x times cosine x to the negative 1. Well, now u is equal to sine x, v is equal to cosine x to the negative 1. Let's break that up into its constituents. So that's a chain rule. So we're doing it with chain rule, product rule. This is a chain rule, and then that's a product rule. So u prime is equal to cosine x. V prime is equal to negative w to the negative 2. W prime is equal to negative sine x. So we've got u prime is equal to cosine x, just rewrite it. V prime is equal to negative, make that sine x times cosine x to the negative 2. And then we can just do it in whatever order we want. Boom, boom. So this times that is sine squared x over cosine squared x. And then this times that is cosine x over cosine x. And so we have y prime is equal to sine squared x over cosine squared x plus 1. Now this isn't looking the same. but it is the same. This is tangent squared x, and this is 1. And if I look at my Pythagorean identities, if I divide all of this by cosine squared x, I can see that tangent squared x plus 1 equals secant squared x. So this there you go. So that's how you get the derivative of tangent x, using a quotient rule or also chain rule product rule, and also using some trig identities, which are really, really important to remember.